Assalamualaikum and hi everyone! We are group 7 from AS1203I and my name is Nur Amna Inshira binti Abdul Aziz and my teammates are Nur Atira binti Anwar Fikri, Nur Alia binti Muhammad Zailani and Nur Aliana Azma binti Izzat Fahmi. Today, we will be sharing something you might already love. Wow, what is that? It's green tea. But this time, we will be looking at it from a chemistry point of view, focusing on its organic compound and medical properties. As you can see here, green tea or teh hijau comes from the Camellia sinensis plants, which belongs to the Thylaceae family. It originally comes from China and East Asia. And for tea, we mainly use the young leaves and buds. So, what makes green tea special? It's all about minimal processing. Unlike black tea, it's unfermented, which means no oxidation. That's why it retains high antioxidant compounds, which is super important for our health. From a chemistry point of view, it contains several bioactive compounds with functional groups such as amide, amine, hydroxyl and also carboxyl, and these functional groups are what give green tea its amazing health benefits. Now let's take a look at one of its key active compounds, L-theanine. The first compound we studied is L-theanine, with the full name is L-gamma-glutamyl ethylamide, and the chemical formula C7H14N2O3. Basically, L-theanine is an aldehyde derivative of the amino acid glutamic acid. Okay, look closely at its structure. We will find three main functional groups. So for homologous series amine, CONH, also known as amido for functional group. So the second one is amine, NH2, also known as amino. And the last one, homologous series for carboxylic acid, COOH, is also known as carboxyl for functional group. Yes, got it. That was right too. So, what makes the L-theanine so cool? Of course, it helps you feel calm, relaxed, but without making you sleepy. And also, it works together with caffeine in green tea, like improving focus, enhancing mood, reducing stress, which lead to better sleep quality later on. And then wraps up my part of the introduction and L-theanine. Now let's move on to another exciting compound, and I will pass it over to Ira, who will continue with caffeine and explain how this works and its amazing effects. Thank you!
Hi, I am Nur Atira, and I'm gonna talk about the second active compound that has been found in green tea, which is caffeine. Have you ever wondered what structure formula of caffeine looks like? It looks like this. As you can see the structure formula of the caffeine, there are several functional groups and homologous series that I'm going to show you. The first homologous series is ketone. Ketone has a functional group that called carbonyl. Carbonyl is a C double bond with O, and the two bond that has left is bonded with R. The second of homologous series is called alkene. Alkene has a functional group called double bond, which is C double bond with another C. So basically, C has 4 bond and 0 lone pair. So what makes it called double bond? Because the C that bonded with C has a double bond that are like double-decker. That's why it called double bond. The third homologous series called amide. Amide has a functional group that called amido. How do we know the functional group is amido? How do we detect that? So, amido is a carbonyl group that attach to the amino group and hydrogen. That is called amido, which is amino group in here is a nitrogen. The fourth homolog series is amine. Amine has a functional group that called amino. How do we know it's amino? So, if the nitrogen bonded to the alkyl group or hydrogen, that is how we know it's amino. But in this caffeine structure formula, nitrogen attached to the alkyl group or a branch named methyl. So that is how we know it's amino. Now, let's talk about the role of caffeine in green tea. How can it affect us? So the first one, caffeine can improve our attention and concentration towards something. How? So basically, caffeine can activate our nervous system and makes us feel more awake. The second role of caffeine in green tea is that caffeine can act as a quick energy boost too. But how? Caffeine in green tea are balanced out with L-theanine compound that has in green tea, which is it gives us a effect of really calm alertness rather than sharp spike from other caffeine, such as caffeine from coffee. The third role of caffeine in green tea is that it can reduce the feelings of fatigue. But how? So caffeine works by blocking adenosine, which is a neurotransmitter that builds up during the day to make us feel sleepy. With caffeines, it can really energize us. The last role is caffeine can improve our brain's functions. But how? Again, caffeine can make our dopamine level increases and reduces the level of anxious.
Hi, I will present about active compound that called epigallocatechin gallate, commonly called AGCG. AGCG, a major bioactive compound in green tea and a key molecule in nutrition and medicinal chemistry. In this slide, I will explain its structure, chemical name, chemical formula, functional group, homology series, and role of epigallocatechin gallate in green tea. First, I will start with chemical structure of AGCG. It's a polyphenol made up of several aromatic rings and multiple hydroxyl group attached. Its chemical formula is carbon 22, hydrogen 18, oxygen 11. You will also notice the 2R-3R descriptor in its chemical name. This indicates the stereochemistry at carbon position 2 and 3, which are chiral center. Each chiral carbon is connected to 4 different groups, so it can have different 3D arrangement, like mirror image. This 3D structure is important because it affects biological interaction and activity. Next, functional group. Breaking it down by functional group, AGCG contains hydroxyl, benzene, ether ROR linkage, and a carbonyl plus alkoxy. Then is homologous series. Chemically, AGCG fits into multiple categories because of its combined features. For highlight color pink is alcohol due to hydroxyl group. Then color blue is aromatic compound because of benzene rings. Next is ether in color purple for ROR linkage. Lastly, highlight in color yellow is ester for the gallate ester. This classification helps chemists predict reactivity, solubility, and transformation pathway. Role of epigallocatechin gallate in green tea. Firstly, green tea acts as a strong antioxidant. This means it helps protect our cells from damage caused by free radicals. It also has anti-inflammatory effects, which can help reduce the risk of chronic disease, such as arthritis, heart disease, and certain cancer. Next, AGCG good for heart health. Heart disease is one of the leading causes of death in Canada. Fortunately, research showed that green tea can contribute to better cardiovascular health. Studies suggest that regular consumption of green tea may help lower cholesterol, reduce blood pressure, improve blood vessel function, and decrease inflammation. Other than that, EGCG is good for weight loss. Many people drink green tea to support weight loss. Research shows that green tea can increase metabolism and fat burning, especially when combined with a healthy diet and exercise. Lastly, EGCG is good for brain. Study also suggests that EGCG supports brain health. It may protect against diseases like Alzheimer's and Parkinson, and it can even help improve our memory and focus.
Now, I would like to share the active compound that we found in green tea. So here, we already shared the structural formula. And from that, I have found 3 functional groups and also 3 homology series. So the first functional group is hydroxyl, alkoxide, hydroxyl. So the homology series for hydroxyl is phenol, then alkoxide is ether, hydroxyl is alcohol. So now we look at the role of catechin in green tea. So the first, metabolism and weight control. Catechin help to boost metabolism and increase fat burning. And the second one, anti-cancer. Catechin potentially prevention from the risk of cancer such as lungs, esophagus, stomach, intestinal, breast, prostate, bladder cancer. And the last one is antioxidant. Catechin help neutralize free radical and also protecting cell from damage. Now, we look at the next active compound, which is gallic acid. Here we already shared the structural formula. So from that, I have found 2 functional groups and also 2 homology series. So the first functional group is carboxyl and the last one is hydroxyl. So the homology series for carboxyl is carboxylic acid and the homology series for hydroxyl is phenol. Now, what are the functions of gallic acid in green tea? So the first one, gallic acid can improve insulin sensitivity and glucose metabolism. And the second one, gallic acid may also play a role protecting the brain and nervous system. And the last one, gallic acid proven to be an effective anti-inflammatory agent, so it can reduce symptoms of arthritis, lupus, and other inflammatory conditions such as allergies.
Benefits of green tea. How can green tea benefit us in traditional way? So the first one is, traditionally, green tea can control blood sugar levels. For example, diabetes people has been consumed green tea to control their weight. This is because green tea can regulate glucose in our body, turning them into the energy rather than keeping it as a fat. Secondly, green tea has been used traditionally to control bleeding and to help wound heal faster. For example, if you get a cut on your hand or on your body, you can use green tea leaves as an ointment to help the cut heal faster. Or you can make a green tea from that green tea leaf and drink it to make the wound heal faster too. In this situation, green tea acts as an astringent.
For modern medical uses of green tea and what current research suggests about its health benefits. First, anti-cancer potential. Green tea has been studied for its anti-cancer properties. EGCG in green tea can slow the growth of cancer cells and encourage damaged or abnormal cells to destroy themselves naturally. Second, brain and cognitive functions. It helps protect nerve cells and may lower the risk of neurodegenerative disease like Alzheimer's and Parkinson's. Green tea contains caffeine and L-theanine, which work together to improve our focus, attention, and memory.